to the Pesticide Action Network, the Centers for Disease Control and Prevention measure pesticides and other chemicals in the bodies of Americans every few years. In the most recent study, they tested for 212 chemicals and found most of them. 212 chemicals are found in the bodies of Americans, and they can be linked back to pesticides. Pesticides are chemicals sprayed over crops to obtain insect control. These chemicals travel through the food chain and make their way all the way up to humans. With this in mind, today I will explain 3 alternative methods of insect control that are less harmful on the environment. 3 ways scientists are controlling insects without using harmful pesticides include the use of chemical sterilants, viruses, and natural predators. To begin, the first way scientists are controlling insects is through the use of the chemical sterilant. The idea behind this concept is to turn a species against itself. Scientists begin this experiment by sterilizing males of a species in a lab. Next, they would release these males into the wild so they could produce with the wild females. The offspring of the wild females and the sterilized males would be unable to reproduce, therefore ending the species. Scientists ran into some issues while discussing ways to sterilize these males. Insects had to match a list of requirements for this method to be successful. Scientists in Florida quickly realized there was an easier way to sterilize insects by poisoning their food. They tested this on an island of the Keys, and fruit flies were successfully wiped out in just 5 weeks. There is great hope in this method for the future as it continues. Rachel Carson, an environmentalist who is most known for writing A Silent Spring, a book about the dangers of harmful insecticides, believes that chemical sterilants could cure malaria once and for all. Sterilants could be successful because they only affect their intended target and they cannot spread to other organisms. Let's move on to another form of insect control. The second way scientists are controlling insects is by the use of viruses. The idea here is to copy nature's processes of wiping out species. Diseases have been around as long as the earth has. Insects can be infected with fungi, protozoa, and even worms. Scientists took special interest in microbes as a method of control. Microbes help humans in many ways, such as destroying waste and fertilizing soil. A zoologist named Elie Metchnikoff pioneered microbial control, leading to many encouraging results. The use of viruses to control species is valuable in many ways. Dr. Leonard Perry, an extension professor at the University of Vermont, states, "Microbial insecticides actually are made from microorganisms that attack insects. Since they are so specialized, they pose relatively little risk to humans." Much like the chemical sterilants, this will only affect its intended target. This is because they stay confined to insects due to the specificity of the virus. Lastly, the third way scientists are controlling insects without negatively affecting the environment is the use of natural predators. Using insects' natural enemies dates back to Darwin's time. There are hundreds of natural predators of insects. For example, a Japanese wasp helps protect apple orchids from insects. Natural enemies of the alfalfa aphid, an insect harmful to alfalfa, helped control the species in weeks. This method saved millions of dollars in California alone. Despite its success, California is the only state with a formal program for this method. It lacks popularity, however, it will hopefully be implemented in the future. Introducing these predators, such as a wasp or bird, is inexpensive, permanent, and leaves no poisonous residues. To wrap things up, today I have informed you about alternative ways to control insects without causing harm on the environment. These methods include, but are not limited to, chemical sterilants, viruses, and natural predators. I hope today I have opened your eyes to safer and more successful methods of insect control.